Hello everyone, welcome to 241 probability. And we're going to start with chapter 1, the combinatorial analysis. This video is on the basic rule of counting. Let's start with a definition here. Suppose an experiment consists outcome 1 and 2. And you know that there are n1 possibilities for the first outcome and n2 possibilities for the second outcome. Then together, there are n1 times n2 possibilities for the experiment. The key here, as you can see, is that, well, you have two outcomes, okay? And then for each outcome, you have different number of possibilities. And more importantly, the experiment consists of the two outcomes, right? You have to have the two outcomes together in order to finish this experiment. So because of that, you are multiplying these two together, okay? Let's look at example. A team of one boy and one girl is to be made from a group, form a group of 5 girls and 2 boys. How many different teams are there? And we have a definition here. Team A is different from team B if at least one player is different. Okay. So the question is, as you can see, we have 7 people, right? 5 girls and 2 boys, and we're choosing 1 girl from it and 1 boy from it to form a team. All right. How can we deal with this? One way to do it, as you can see, is that we're listing all of the possibilities, okay? And each case, in this case, the number of girls, well, girls is outcome 1 and boys is outcome 2, okay? So, and then you will see that we're adding the subscript here just to show the different girls and boys that we have. So G goes from 1 to 5 and B goes from 1 to 2, okay? And we know that team A is different from team B if at least one player is different. And in order to get that, we are able to list all of them out here, or we can directly use the basic rule of counting as we just discussed from the definition. So we have 2 outcomes, right? And then for the first outcome, selecting a girl, we have 5 possibilities. So that's n1 equals to 5. And for the second outcome, we have 2 possibilities for the boys. So the number of outcomes, well, I should say the number of possibilities for the experiment in total is 5 times 2. So that's the basic rule of counting. And then, of course, you might be wondering, what if you have more than 2 outcomes, right? So the generalized rule of counting we're introducing here is suppose the experiment consists R different outcomes, and each of this, and in particular the ith outcome out of the R outcome, is having n subscript I possibilities, okay? Then together they are producting n1 to nr number of possibilities for the experiment. So this is generalized, as we call it, because now you have more than 2 outcomes, okay? And the reason of it will be very similar to what we had before, okay? But let's look at the notation a little bit. The left-hand side is what we know is just multiplying all of the different R, A, and I's. And short form for writing this, as you can see, is the right-hand side, okay? And this big pi is the product symbol, okay? And then what we're producting, as you know from the left-hand side, is that we're taking the product of all of the ni here, okay? Remember, we have the subscript I, okay? So the product sign that we're using over here can help us to indicate exactly how we're producting of them, right? So we know that we're taking the product from n1 to nr. So you can write I goes from 1 to r. 1 is below the product sign, 1 is above it. And then this together implies that we're taking the product of all of this n different ni values, okay? So that's the definition, and let's look at example. How many different license plates are there, okay? And you can see that here we define a license plate of 6 digits. The first 3 has to be letters, and the last 3 has to be numbers, okay? And for the letter, we're just gonna say that you have to choose from the 26 capital letters, okay? So to answer that question, this question, using the generalized rule of counting as we know now, is that, well, the first letter, the first digit has 26 letters that we can choose from, right? So that's the first outcome with 26 possibilities. Second is also 26. Third is also 26, okay? And numbers is 0 to 9. So there are 10 different choices. So it's going to be 10, 10, and 10 here. Okay. And then this is just writing out, right, the number of possibilities for each outcome. And then in the end, because we're trying to answer the question of how many different license plates are out there, you are taking the product of all of them. So just multiply all of them together, which will give you a really large number here. Okay, so this is, well, not surprising, right? And not surprising in a sense that we don't see duplicated license plates that often. And then, of course, if you start to consider the cases where different states are, then you might even have more number of possible license plates out there. Okay. All right, so this completes our discussion and introduction of the basic rule of counting. We started off with 2 outcomes. So it's the product, the 2, N1 and N2, each represent the number of possibilities for each outcome. And then we introduced the generalized version of it, okay? And then where you have R different outcomes, and then each you have an NI possibilities. So you're taking the product, and then we introduce the notation of the product like a big pie over here.